Welcome to EDU World Space.
All right, so in this problem, so we have a steel rod, and which is connected by a copper wire, and we know the length and the diameter of the rod, and we also know the length and the diameter of the wire. So in part A, we first need to determine the resistance of the whole setup. So basically, the whole resistance equal rho steel times L steel divided by A steel plus rho copper times times L copper divided by A copper. Okay, so you can find out the length and the diameter from the problem. And for the steel, the resistivity is 20 times 10 to the negative eighth ohm meter. And for copper, it's 1.72 times 10 to the negative eighth ohm meter. Okay, so you can find out the value of the resistance is 1.35 times 10 to the negative 2 ohms. Okay, so the potential difference simply equal to R times I, right? So I is the current in the lightning bolt, which gives you 203.2 volts. Okay, and in part B, so we want to find out the power dissipated in this setup. So power is simply equal to I squared times R, and this gives you 3.05 times 10 to the 6 watts. So total energy dissipated in the setup is equal P times T. So T is given the problem. So this, you will see that this equal 198 joules.